Good morning, YouTubers. Looks like a beautiful day to stay inside and work on my bench power supply. I was just looking at some videos from about power supplies, and I'm just going to verify that this power supply is actually working. I'm going to plug it in to my power bar here. I'm going to plug this in here. Or plugged in for my soldering iron. Yep, power on. Let's crank up the heat. Maximum 60 watts. This is 18 gauge wire that I stripped down to 20 gauge. And all I want to do is just tin the end of the wire. Okay, there you go. The wires are tinned. Test fit inside. Nice snug fit, holding fast. Okay, let's get this into the correct pins, which was the green and the black. There we go, green and black. All right, we've got the green and the black wire jumpered now. We're going to test the power supply's power to see if the fan comes on. All right, let's take our power supply cable and plug it into our power supply. And there it goes. As you can see, the fan turned on and the fan is going to shut off. So my jumper lead works on the green to ground sense wire. Okay? One consideration to think about. Next. Okay. Let's take a look at this mess of wires and see if we can get some voltage readings. So I'm going to put the red positive lead there on a ground, which is right here. What's that coming up? 5 volts. Let's jump over to the orange one. Should be 3.3. This one here, 3.3. Let's go to the red one, 5.50. Okay, everything's coming up the way it's spec'd. Just for fun, I'm going to see what the gray wire yields. Make sure I'm on the ground. That's the gray. The gray is coming in at 5. The purple wire beside it, curious about that as well. grounded here, the purple. Purple's coming up at 5.10. The yellow, 12.12. The yellow again, 12.12. The orange wire, 3.3. And on the other side, got several reds, a green wire which I've jumpered, and a blue wire that I'm curious about as well. So let's get a ground on that. And see what the blue wire is yielding. The blue wire appears to have 11.96 volts on it. Now the blue wire is supposed to be negative 12 volts, and it is. It's negative 12 volts. My apologies. All right, get ready, boys. Grab your tools. We're going inside. I've got my lovely Pick Quick screwdriver that I love, Canadian made. I have a Phillips number 2 bit, 6 inches. Doesn't have to be that long, of course. This is my workbench. Not really, but it is today. We're going to unscrew the top, get the cover off. Okay, just make sure we're all situated just so, and voila. Cover comes off, exposing the guts of this beast. Well, it's not really a beast. And please exercise caution when handling the product, especially after it's been plugged in. So I'm just going to set this down and get ready for the next step of this process, which is to harvest the 12, the 5, the 3, and the negative 12 leads, and create a manageable output that I can use. I'm just going to start cutting. Okay, I'm going to take my Radio Shack cutters here, and I'm just going to start cutting wires. Alright, here we go. Here goes nuts and honey. Same lengths here. Okay, so now we have a power supply with all the leads cut to approximately the same length. Heat shrink. There we go. Zip tie gone. Same thing at the other side here. Get that zip tie. Just like that. Take that off. Save that for another application if you want. Okay, so now we've got our wiring bundle here, our wiring harness. We've got to sort out all the different colored wires. There's another one. Okie dokie. Now that all of the wires have been freed, just one more time, I'm just going to make sure that this wiring harness or bundle of wires is evenly cut. So you can see a lot of the wires are of different lengths here. I'm just going to start cutting them again, trimming them. Just keep chewing through that bundle. Just like that. Chomp, 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 chomp. Just keep cutting through that wiring until you get all your wires at an even length. I still don't know what this wire is, and I'm reserving it for future consideration. So I'm just going to pull that out of the wiring bundle here. Just unraveling some of the wires here so that I can pull off this wire to the side without affecting or interfering with any of the other wires. Okay. When you work in tight spaces like this, you must keep a clean work area. So, give me a moment here and let me clean up this mess that I've created. My jumper lead that I cut and I soldered, tinned the ends for a 20 gauge hole, I'm keeping that for sure. That's useful. That I'm keeping. So I'm going to separate out all the yellows. 1, 2, 3 here. 4, 5. For this demonstration, I'm only interested in the 12 volt power supply, so separating out all the yellows. This one is yellow and black. I don't know what that means. For all intensive purposes, I'm going to suggest that there is two 12 volt rails on this power supply. One is probably yellow, the other one's yellow and black, and that's possibly the second rail. It's like doing yellow, black, yellow, black, yellow, black. Another yellow. Another yellow one here. That's yellow, black, yellow, black, yellow, black, and yellow, black. Curious why those 4 wires are yellow with a black stripe on it. So now, let's separate some ground wires out. All of them. Okay, that leaves these colored wires. Now I gotta unravel the black ones. It's a bit of an arduous task unraveling the wire loom. Persevere, sustain, hold the position, forge ahead. You will get through this process. And there's your cheering section. Yeah! Yay! Oh, William Prince. Oh, I thought you were cheering for me. Listening to the radio. Supposedly something relaxing. And that's what I encourage you to do, is find something relaxing while you go through this process, because it is an arduous task and it will challenge you. And if you don't remain focused, you could end up, well, you're not going to could end up, you are going to end up a little bit frustrated, annoyed, aggravated, agitated, etc., etc., etc. So, here we go. We've got it all done. See, it just takes a little bit of effort, and you will get to the place, to the happy place that you want to be at. Okay, so we're going to separate these groups of wires here. This black and yellow, or yellow and black stripe group, I'm going to separate. Here's all the grounds. Here's all the 12 volt leads. All right. Next step. I just want to separate that's the yellow with black stripe. I have again 1, 2, 3, 4, 5, 6, 7, 8 16 gauge wires in this group. In the same sense, for the ground wires, if I have 8 of these, I'm going to have 8 ground wires. I just need 8 ground wires. 2, 4, 5, 6, 7, and 8. So if I group this together, and I group this together, I'll have a 8 times 16 gauge. I'll have to do the math. I'll get back to you on that. But I'll have the negative and the positive, same gauge, 16 times 8, going into my power amp. That's going to drive the subwoofers. Alright, I'm just trying to get a little bit of control over everything here. Taping everything up. Now, okay, group that together nice and snug and tight. We're off and running. I've got to strip the ends of these wires, but before I do that, I need to make sure that they're all equal. Just like that. Not exactly. I want to remove a fair amount of material so that my finished end is, well, you'll figure it out. You'll see as I go along here. One more here. Okay, so now that you've got all your wires stripped down, you gotta start raveling them all together. Line it all up. Okay, everything's sort of lined up there. Get that all twisted together. Just like that. It's almost like an 8-gauge wire now. Okay, here we are. I have just grouped together all the 16-gauge yellow wires, 8 of them, and I've braided them together, and now I'm going to solder this. I've connected a zip tie to the remaining bundle of wires that I'm currently not interested in. I'm just going to trim off the excess zip tie. I now am going to strip the negative wires, but likewise with the yellow wires, I'm just going to trim them off so that they're all equal. And again, I have 8 of them, 8 16-gauge negative or ground wires. 2, 3, 4, 5, 6, 7, 8. And I'm going to end up with the same profile as this positive lead. Okay, let's get these wires stripped. The remaining negative leads are getting stripped down. Once all the wires are stripped, you just line them up, essentially. Line them up and then give it a little twist, and then you'll be on easy street. There you go. Okay, one negative, one positive. Just gonna tie up the end here. Let's get the soldering iron warmed up. Okay, we're all set up here. I've just turned on the soldering iron. It's warming up. I've got my negative and my positive 12 volt all sorted out, ready for some solder. I still have to get my sense wire organized for the power on, and I'm going to do that next. I'm going to add some shrink tube. Okay, so I'm going to cut through the heat shrink tubing with an X-Acto knife. Just going to cut off a couple of lengths here. I'm just going to slip it over my connections here. Whether I do it before or after I solder it, I don't really care. But going to be a little better cable management system. Basically, once you get that all shrunk together, you get that soldered together, things are starting to come together, they're starting to look up. Okay, my soldering iron's warmed up, my solder is at the ready, my wires are ready to be soldered. I am tired. It's been a long day and I'm ready for bed, and I got to get up early tomorrow, and I do not want to do this, but I want to finish this process tonight, just get that mechanical stuff out of the way, and then tomorrow I can figure out how to do all the connections to the power amp, etc. Alright, let's get this going. Let's get this soldering job on the go. Yeah, the solder, she's melting. She's melting all right. Just need it to wick into the wire a little bit, and then it'll just suck right in. It's capillary action, sucking it all into the wire. Filling that wire full of solder. Same thing with the negative. Yes, 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 indeed. Okay, I have just turned off my soldering iron. I've just finished soldering the negative and the positive leads. Okay, you get the idea. I want to show you a quick detail here. I've got the heat shrink attached. I've got my cables soldered together. Just want to square up the ends a little bit. Just going to cut off a nice square edge off the tip of both of my leads here. They're going to tie into the power amp. Okay, just wanted to show you guys that. This power supply is all but ready to power my power amplifier, to power my subs. That'll be tomorrow's job. Thanks for viewing. What am I going to do now, you might ask? Well, we're going to look at the switch. And what I'm trying to do right now is I'm trying to turn on the power supply with a switch. And I'm going to do that using the green wire from this wiring harness and a negative wire connected to this switch here. So basically it's just get the iron hot, strip your wires. These are smaller gauge, this 16. This green wire is, I'm going to say it's 16, but it's not. It's actually 18 gauge. 18 gauge wire. Just cut it, strip it. There you go. One of these negative wires. Strip it like so. This is how I like to solder my joints. How I like to do soldering of these wire splices. So I do exactly that. It's a splice.
Nice. So that is how the power supply gets wired up together.
Come on, come on. Okay, this is the switch that I'm using. It came out of a handicap door closer, opener. And it's a low voltage wire system that operates in those door openers. This is rated for 10 amps. It's a lot better quality switch than what is required for this power supply right here. So I want this to sit in such a way that I can get a soldering joint on there, and it'll be flat, square, level, plumb, for lack of better. I want a nice straight line. A little more manipulation. A little more twisting and turning, and a boatload more of solder. Whereas I'm just a hacker. So this is how I hack my way through my projects without the necessary tools to do the same thing. And it's putting pressure on the wire, which is making good connection to the wire to the soldering iron, which is heating up the wire and the soldered connection, and it goes a lot more quick when you actually have good contact with your okay, well, there's a couple of ugly looking soldering connections, but they are good. There's my switch. I turn the power supply on and off with it, just like that. Now what I need is some electrical tape to insulate the wire so that it doesn't short out. Edit all this conversation out, and you're just going to see me doing the little pieces of. So first thing I want to do is, well, let's take a closer look. Let's see if the fan comes on when the power supply is turned on, okay? This wire sends out a continuous 5-volt supply, even when the power seemingly is turned off and the power supply is not running. And we're going to verify that right now with this ANOVA 3340A multi-tester, which I love. I use for my car electronics a lot. And I use it for home-based projects because it has some of the same features that I am trying to troubleshoot or assess. So this is off, this is on. Even though it looks and appears like the power supply is not on, you have to still exercise some caution when handling electronics, okay? As we're about to find out, there is some power coming into this power supply. Alright, so I've got my switch turned to off. We're going to take the voltmeter, where I've already plugged the negative to a negative from the wiring harness. I'm going to take the positive and put it on the purple wire and watch the display on the multimeter. 5.11 volts DC. 5.1011. So that is your standby power. That will be able to power a USB type connector that I'm going to build into this project so that you could charge any USB device off of this power supply, even though it is turned off and not being used for its general purpose, which is going to become self-evident soon enough. Soon enough. Be patient. Okay, let's check some other power, other leads here to see what might be coming through this power supply with the power turned off. Okay? Or on from the back. Gray wire, nothing. Blue wire is supposed to be minus 12. Nothing there. And the brown wire, which, to be honest, I don't know what it's for. So, I'm going to turn on the power supply now and do another reading. Just to show you, the power supply did come on and the fan is turning. I turned on the power supply and the fan is turning. The fan is turning. Okay. Let's check these again. Gray is 5.07, 5.06 volts DC. The purple wire, again, still outputting 5.10 or 11 volts DC. The brown wire, I'm curious about. That's the 3 volts. Okay, yeah. It's all coming back to me now. 3.3, and the blue one should be negative 12. And sure enough, the little negative indicator came on the display here at 11.96 volts negative DC. Okay, moving forwards. That is the on-off switch that is connected to the green sense wire. The gray wire is a another sense wire or a power regulating wire that tells the power supply to put 12 volts here. The logic, I guess, somehow, some way it's connected to the logic. The purple wire is the 5 volt continuous. Brown here is 3.3 and blue is the minus 12. So I want to check my main power here. Again, I still have it connected to this negative lead here, but just for fun, we're just going to disconnect that, connect it here. All the negatives are all connected in the same place on the PCBs or on the power supplies circuit board. All right, here we go. That's connected to the yellow wires. That's connected to the black wire. And we're getting 12.12 volts DC, which is good. That's what my goal was, is to get the 12 volts. Okay, just going to disconnect that. All right, just quickly here, I just was tinning the ends of these wires. Just got all my wires tinned. I'm going to test out a LED and resistor and see if I can get some lights, camera action going. That's the next step. Alright, I was just testing the resistance of the resistors. So this is kilo ohms, 9.97 kilo ohms. It's out of my range. Looking for something 180, 200-ish. Okay, what do we got here? Oh, there, 215. Yeah, close enough. I'll use that. Use one of these resistors with the LED light here. I'll solder that together, and then I'm going to connect it to my wires here and get some lights going. Okay. Okay. I'm trying to see if I can get this LED to light up. And I'm just realizing how difficult it is to try to hold a resistor and a wire and a soldering iron and solder all at the same time to create a joint, a soldered joint. So now I'm gonna put my beer can to work for me. I'm gonna get you lined up at the right height. The elevations are correct. To make my solder connections, I gotta go down just a little bit more, just a touch more like that. And verify that it's too low. I'll just bend it up a little bit. Okay. Now this is where I want the connection to be. That frees up my hands now, and my cord on my soldering iron's too short to reach. I can't work with it this way. I have to work with it this way. And I'm not left-handed, I'm right-handed, but hey, I'm learning. I'm learning all the tricks, how to do, what to do. Now hopefully I can just solder this together. If it'll stay. Come on. Okay, it's melted together again. Oh God. I'm afraid to pull on it. Just keep feeding solder in there and hoping that it might eventually connect. How's that? Like that? Okay, so the negative. See what kind of voltages might be coming across here. Okay. There's that. Gonna turn on the VU meter. the multimeter and set volts DC. I'm going to flick the switch on the back of the power supply to feed current to the 5-volt purple wire and see if the LED lights up or if it burns out. There goes nothing. 3, 2, 1. Whoa! We got a green light. We've got a green light. And there you go. Lights, camera, and action. So that's working. I haven't even turned on the power supply yet. It's still in the off position, meaning there's no voltage going to any of my leads in the wiring harness. Let's take a quick test and find out if indeed there is some power going through any of these leads. 0. Okay, 0.1 millivolts. I don't want to bore you with all the other connections here, but take my word for it, they are not active. Okay, let's turn on the power supply with our switch here. Okay, the power supply just came on. Let's check again what kind of voltage we might be having on this rail. There it is, 12.12 volts DC output. How many amps? Okay, let's try it this way. A couple of jumpers. The white is neutral, and the other ones relate to the colors. So I'm going to pick the blue wire for the blue lead and see if we can get some juice. I'm working upside down and backwards. That way it lights. See the load on the volt side, 11.98. Then back up to 12.12. So the draw is 2 plus 12. That's 14 milliamps. Or sorry, millivolts. Approximately, I want to say. Okay, let's turn everything off before we get electrocuted. Watch the voltage drop off again. I'll take this, put it back in its package. Okay, little more detail with the LED and the resistor. 5 volts. Power supply is off, but it is still on. AC power is still flowing into this power supply and feeding this purple wire with 5 volts of electricity. Now the way I've got my lead hooked up, I wanted to see what the resistance, this resistor I think is 47 kilo ohms, no, sorry. It is a 220, it's a 220 ohm resistor with 5 volts coming in on that side of the resistor and 2 volts coming out on the other side of the resistor, just to show you how much that reduces the power going to the LED. Now, I'll reconnect that back to the purple wire. Back at 5 volts. Computer, our power supply is turned off by all intents and purposes. These leads and this wiring harness is all shut down. But now I'm going to turn off the power supply. Let's watch the voltage drop off and the LED go out. It might take a few moments, but that's because of these bad boys right here. Those capacitors will hold a charge for a while. There it goes. Boom. Dropping like a rock. The LED just went off. So if you're not careful, you can get a good jolt of electricity. I'm going to put the screws back into the case, like so. Let's get working on getting the power plugged in. Okay, just a little more work, a little more soldering. Grab an LED here. Let's grab it. I'm gonna solder the black wire up here. Gonna do the same thing, do a little twisty. I am done with that. I'm going to do one more thing here, and the remote turn on for the amplifier is going to be a 12 volt source. So I think I'm going to use this wire right here. It's got with the black stripe on it. It provides 12 volts, and I'm going to put that one right in here for the remote 12 volt sense wire. When 12 volts comes on here, it turns on the amplifier and it feeds the 12 volts into the amp. The main supplies. So let's get those ones hooked up as well. I want you to see a little closer detail of how this gets screwed down. If I unscrew this, there's the remote, there's 12 volt positive, this one's the ground. You just unscrew them like that. And you take your source wires here and plug them in. I was curious about the length of the wire, and I'm probably going to shorten that up right now. My assistant back to work here. I just wasn't sure how deep the jacks were, receptacles. Shorten that up a little bit. Now it fits in there flush, tight. Same thing is true with the positive lead here. I'm going to cut off a little bit of it so that it stays protected inside the housing. Just like that. Look, it got me. That hot iron got me. I just turned it off. I'm doing everything, trying to be careful. And I still get scorched. Scorched. Okay, I have made an executive decision. I'm actually going to switch literally put a switch on this 12 volt remote turn on. Okay, just put on a little bit of heat shrink, finish soldering. I put the switch wire into the remote turn on for the amp, the power amp. Crank that down so it's secure. Make sure all your wire connections are solid. You don't want any shorts. Just make sure it's all clean. Alright, so power switch to turn on the 12 volt sense wire to the remote turn on for the amp coming from the power supply. Switch turns on and off the power supply using the green sense wire shorted out to the ground. I've got a LED hooked up to the 5 volt supply that's constant when the power amp is turned on with the AC. And I've got a LED hooked up to the gray wire to just indicate that there is proper function within the unit itself. Right, back in business, just doing a little bit of housekeeping here. Want to clean up, got some isopropyl alcohol. Just want to clean up any flux and any solder that might have stuck to my workbench table, my 1 square foot. Okay, there you go. All back to normal again. This switch belongs over here, and this switch belongs over here. There we go. If it'll always stay put. Grab your Allen key. Negative and positive. Make sure you got polarity correct. I put my polarity on the writing on the wire, so the writing is my positive and the blank wire is the negative. Secure these connections. Yep, that's good and tight. Alright. Okay, getting really close here. really close. Don't want to push on it too hard because it'll slide and the amp will fall down. I'm going to have to use both hands to secure that. Alright, getting closer. Make sure all my switches are off and off. Okay, making sure that the plug is seated properly, which it is now. Alright, it is playtime, boys and girls. It's playtime. Let's get playing. I've spent hours and hours and days working on this project, this wonderful project. My main intent was to get the JL Audio 500 watt power amp hooked up so that I could use my JL Audio subwoofers that I built the boxes for. And this one is not connected. I say this one, and you say this one. What? There's more than one? Oh, yeah, there's more than one. Of course there's more than one. You have to even ask. Here's another one right over here. We got this other JL Audio sub sitting here, sitting pretty at the ready, waiting, just waiting to be thumped and pumped and fed vast amounts of electrical current. So I have done so much. I am currently monitoring the temperature of the amplifier. Yeah, but it's not on, so what are you measuring, right? Well, I'm not measuring much. I've been testing it. I've been also testing the output of the power supply here from Antec, 500 watt power supply, and it's running at about just under 20 degrees Celsius. Or if it burns out, here goes nothing. 3, 2, 1. Whoa! We got a green light. We've got a green light. Hey, welcome back. Just wanted to show up close some of the technology that I'm using right here, right now. We got the Allo Piano 2.1 plugged into a Raspberry Pi 3B Plus. I've got an external SSD hard drive plugged into the Raspberry Pi, power bank, card reader, mobile portable, a breakout USB plugged into the PSC here. Got an AD18 SMSL. I've got subwoofers from JL Audio plugged in here and here. I've got my Minimus 7 realistic speakers over here and over here. I have Volumio running right now. I just turned on my another Raspberry Pi with a touch screen here. I just wanted to show you that the graphical user interface works on multiple platforms. It works on the Raspberry Pi with touchscreen. It works on the PC plugged into a monitor. It works on your smartphone, and otherwise all the connectivity you could possibly want I have a power amplifier plugged into a power supply that is feeding power to these subwoofers here and here, and the power that's feeding the Minimus speakers is coming from this little amplifier that's rated at 80 watts times 2 at 4 ohms. Yeah, lots of great connectivity, lots of great technology, and loving it. Hope it sounds good as it does. I hope it sounds as good to you as it does to me. Alright, appreciate you watching. You take care of yourselves, and hope to see you in another YouTube video. Give me the thumbs up, or if you prefer, thumbs down. Thanks a lot. Thanks for watching. Have yourselves a super day.